Yeah, so hey guys, today we'll be discussing the Codeforces round, which is 993, I think. Yeah, 993, which is the four round. And today we'll discuss the problems A through G2, the first eight problems. So let's get started. Uh, this is like the title A easy problem. That is actually it describes how it is. So the problem is you are given an integer n, like you want to know how many ordered pairs of positive integers there are such that a equals n minus b, right? So you are given n and you have to print the number of ordered pairs of positive integers such that a equals n minus b. So this is like I think a doable question. Like that would be an overstatement, I think. Like you are given n, 1 minute, and you have to find out the number of ordered pairs such that a equals n minus b. Wait a minute, just a minute. Just a second, guys. Okay. Yeah, so the problem says that you have been given an integer n and you need to print the number of possible positive integers such that a minus, wait, sorry. Yeah, such that a equals n minus b, right? A equals n minus b, which means that a plus b equals n, and a and b, they are to be greater than equal to 1 because they're positive integers. So basically we can see that if a is 1, then b will be n minus 1. Then if a is 2, then b will be n minus 2, and we can go up to n minus 1. So b will be 1. So all of these are the possible solutions which are n minus 1 ordered pairs. So you just had to take the input of n and print n minus 1. So this was the first question. I'll just show you the code. Like even though it's not necessary, I think, but I'll just do that. Yeah, so this is the code. C in n and C out in minus 1, right? So I don't think anyone has a problem with this. Okay, so let's move on to the second problem, which is this. Okay, so the problem says that a string consisting of only the characters P, Q, and W is painted on a glass window of a store. Ship walks past the store. Ship is a person who walks past the store, standing directly in front of the glass window, and observes the string A. Ship then heads inside the store, looks directly at the same glass window, and observes string B. So you are given the string A, and we have to find the string B. So basically, the task is that, like I can say now that we are given the string A, and we have to find the string B such that A is the mirror image of B. Like I think you can all agree to this, that if if there's a glass and there is a string written on it, so if I view it from both the sides, they will be like this of each other, mirror of each other. They will be mirror image of each other, right? So you are given A I have to find B. So let's say the string is, suppose it only contains P, Q, and W, right? So let's say it is P, Q, and P, W, P. So the mirror image would be Q, W, Q, right? Because this becomes this, W becomes W, like because W doesn't change on taking mirror image, and P becomes Q, right? So that's what you have to do. You have to just reverse the string. Like if the string is PWP, then first you will do QWQ, and sorry, first you will do like the string is PWP, then you reverse it, so it becomes PWP. Actually, this is a bad example because the reverse is same, but anyways, and then for all P you just print Q, for all W you just print W, for P you print Q, and like for Q, if there was a Q, suppose there is a Q here, then after reversing, it would become like this, and for every Q you would print P, right? So this is, I think, understandable. I'll just show you the code. Wait a minute. Yeah, so this is the code. I just took the string S as input, then I reversed it, and I looped through it. Then if S of I is equal to W, I printed S of I, and otherwise it is either P or Q. And if it is that, then basically I just did a trick here. Like this is to make the code shorter, but I think it just made it longer, I guess. If I just had done else if SI equals P and else, then I think that would have been shorter. But anyways, I did this. Like this is simple to understand that if SI equals P, then P and P would get cancelled and you would end up with Q. And if SI equals Q, then Q and Q would get cancelled and you would end up with P. Right? So that's like I just printed the string in reverse and exchanged the characters. Right? So any doubt?
No, sir.
Wait, I'll just admit. Okay. Any wait, don't say no. Like if you don't have any doubt, uh, don't say no. Like that discourages other people who may have doubts that they won't um, like they won't ask them if you say no. That might happen. So uh, if you have a doubt, then just say yes.
Okay,
So
sir. Sorry.
anyone have a doubt? Okay, I think no one has a doubt. So let's move on to the problem C, right? The name is hard problem, and I think it is pretty easy. So the problem says Ball is the teacher in Paperfold University. The seats of his classroom are arranged in two rows of M seats each. Okay. Ball is teaching A plus B plus C monkeys. Okay. He is teaching monkeys for some reason, and he wants to assign as many monkeys to a seat as possible. Like he wants to ensure that as many monkeys, like the maximum amount of monkeys, are seated. Ball knows that A of them only want him to sit in row 1, B of them want to sit in row 2, and C of them want to sit, like C of them have no preference. They can sit anywhere. Only one monkey can sit in each seat, and each monkey's preference must be followed if it is seated, right? So what is the maximum of monkeys that Ball can seat? So this is also, I think, a easy question. That the question, like basically it says that there are two rows of M seats each. Like this is one row and this is another row. And basically, you have A monkeys who want to sit in this row, B monkeys who want to sit in this row, and C monkeys who can sit anywhere, right? So what I did was basically I sat those A monkeys. Like since C can sit anywhere, we'll put them in last. Like we can put them anywhere. So basically, we'll just ignore them for now. First, I'll seed the A monkeys in the first row. Like if the first row has enough seats, then I'll seat all of them. Otherwise, I'll just seat how many seats are there. Like there are m seats, right? So if m is greater than equal to a, then I'll just seat all of the monkeys, and otherwise I'll just seat m of them. Like other ones won't be able to sit. Okay, and same for the second row. I'll just seat all of the b monkeys if it is possible. Like if m is greater than or equal to b, then I'll just seat all of them. Otherwise, I'll seat m of them, right? So after doing this, whichever seats are left, I'll just fill them up with c, right? Like if there are enough seats left for C monkeys, then I'll just seat all of the C monkeys into those seats, because these C monkeys do not have any preference, right? So this is the solution, I think. So basically, what you can do is you can take min of a comma m. This means how many A type monkeys can sit, plus min of b comma m. So this is how many B type monkeys can sit, and the sum is that how many monkeys I have seated till now. So um, I can basically I can do 2m minus this, right? I can do 2m minus this, and I will get like how many seats are empty, and then I'll fill them up with like the C type monkeys if there are enough seats, right? That's the algorithm, and you can simplify this into like, just a minute. Yeah, so okay, so val is that min of m comma a plus min of m comma b. So like seed these much monkeys, and then I can seed like c more monkeys. Val, if I seed c more monkeys, then it will be val plus c. But if that is greater than 2m, then that means that I don't have enough seats. Like I have seated extra. So the answer would be 2m in that case. Like I'll just fill those seats which are empty with c. I hope this is clear. Any doubt?
So can you explain this part? I'm not getting the concept.
Okay. So um, can you like do you get this, that this part is
Yes,
how
sir.
many? Yeah, you get that, right?
Yes, sir. For C, how you got that? I don't
Okay.
get that part.
So um, what I did was that after doing this, I'll just like this is the number of monkeys that are seated right now, and I'll just seat all of them. Like wait, I'll just erase this part. Yeah, so this is my answer. Like in one case, like first I have seated A, then I have seated B, and then I have seated all of those C, assuming that there are enough seats. But if there are not enough seats, then this value will be greater than 2m. Like there are 2m seats, right?
Yes,
So
sir.
this value will be greater than 2m. Like if there are not enough seats. I mean, if this value is greater than 2m, then that is wrong because there are only 2m seats. So we need to print 2m in that case, which corresponds to that I am taking some of those C-type monkeys and like placing them in the remaining seats. So now all seats are full, which means 2m seats are full. Like uh, this is the grid. This is row 1. This is row 2. Now suppose I am filling this row with 4 A-type monkeys and this row with 3 B-type monkeys, and now I have 3 seats left. Like this is the case for A equal to 4, B equal to 3, M equal to 5, and let's say just wait a minute. Yeah, sorry. Yeah, I was saying that this is the case for a equal to 4, b equal to 3, and m equals 5. And let's say c equals to 6. Okay. So what I'm saying is I have seated seven monkeys, and if there were enough seats, then I would be able to seat all 6 of them. That is, I would be able to seat 13. But since there are only 10 seats in total, I cannot seat 13. So I'll just print 10. And if the total number of seats is greater than 13, then I'll print 13. Like if m was 7, if m equal to 7, then it would be like this, 14 seats. So in that case, I'll just seat them in here, the 6 monkeys. 1, 2, 3, 4, 5, 6. So for answer will be 13. Uh, do you get it?
Yes, sir.
Okay. So
Sos.
anything else? Can you mute your mic? Kanishk Jain, please mute your mic. Okay. So I think I should move on to the next problem. All right. Uh, yeah. So the name is harder problem, which is true. Okay. So the problem says, given a sequence of positive integers, a positive integer is called a mode of the sequence if it occurs the maximum number of times that any positive integer occurs. For example, the mode of 2 to 3 is 2, and the mode of 8, 8 and 7 is any of the numbers like 9, 8, or 7. All three of them occur with frequency 2, and 2 is the maximum. So therefore, we can say that um, like they are the mode, right? That is the definition. And the problem says that um, sorry, it says that we have been given the mode array, right? We have been given the mode array, like prefix mode array actually. Like you gave UFO an array of length n. To thank you, UFO decides to construct another array b such that AI is the mode of the sequence for all. So like basically the problem says that you have been given an array A. Yeah, so you have been given an array A, A1, A2 up to n length hai. And basically what you have been given is that you have to make another array B1, B2 up to Bn such that A1 is a mode of the first prefix, which is B1, uh, and A2 is the mode of the first two elements, sorry, B1, comma B2, A3, and so on. Like A3 is the mode of B1, comma B3, B1 to B3, I mean, and so on. Like, An will be the mode of all the numbers, B1 up to Bn. So you have to find this array. Like you have to make an array which satisfies all of these conditions, that the given numbers are the prefix modes, right? So actually there can exist many constructions, but the simplest of them I think I did. Like I'll explain what I did. First, I'll explain the intuition behind it. The intuition is that the definition of mode is actually very loose. Like the mode of the sequence is any number that occurs the maximum number of times. Like for this array, all frequencies are 2. So any of them can be called as mode. So actually this is very loose, right? For example, if the definition of mode was like out of all the maximum occurring elements, the one with minimum value. So in that case, the answer would be unique. But in this case, answer is not unique for mode, right? So that's why I'm saying that the definition is very loose, and we can exploit that actually. So how do we exploit that? Is that suppose I ask you this, that I am giving you an array, let's say 1, 2, 4, 5, 7, 8, and I ask you what is the mode. Then someone will say 1, someone will say 4, someone will say 7. Like all the answers are correct. All the 6 numbers are modes. All are mode. Like what I'm trying to say is that if an array has all the distinct numbers, then all of those numbers are mode. Do you agree to this? Yeah. Everyone? Yes? Okay. Uh, all right. So, so basically what I did was, let's say we are given the array A1, A2, up to AN. So, of course, the first element would be A1 because we want the prefix of the first subarray to be A1. So, the first would be B1. Sorry, the first element that is B1, that would be A1. Since A1 is the mode of the first element, so it is A1. Then we have A2. Now let's say that A2 is not equal to A1, right? So definitely we would have to have A2 here, because otherwise for any other number, like the mode wouldn't be that. So A1 comma A2. Now let's say we have A3. Suppose A1 and A3 are equal, then I can basically add any other number and A1 will still be the mode. Like suppose I add some A4, sorry, not A4. Let's say I add some dummy variable K. Then the mode of these three, like we can say that A1 is the mode of these three. So basically what I'm trying to do is I'm trying to create an array which has all distinct elements. And we can actually do that. We can do that because the constraint here says that bi must be 1 to n. Like we have to print n elements and all of them must be between 1 and n. So it is possible that I print an array with all distinct elements because I have n values to print and the range is from 1 to n. So I can print that actually. So what at each step what I'm doing is, let's say my array is,
उठ गया
sorry, can you mute your mic? Yeah, okay. So suppose I'll take an example. Let's say 2, 3, 2, 5, 4, 5. Okay, this is the array. So now I have to create B. So first element will be 2, obviously. Then second will be third, second will be 3. Because for any other element, the mode will not be 3. Then we have 2 again. So if I put 2 here, then it is the mode. But that is not desirable. Like what I'm trying to do is, I am trying to make all elements distinct. So suppose I insert 1 here. So still we can say that 2 is the mode of this array. So this is satisfied. Then we have 5. So we want to insert 5 here. Then we have 4. Then so we want to insert 4 here because 4 hasn't come anywhere. Like 4 hasn't come in this prefix. So we have to insert 4 here. And now we have 5. 5 has come. So I have to just insert a number which has not come before, and 5 will still be the mode. So I'll insert 6. So you can say that for this array, 5 is still the mode because all of them are mode. So this is what I did. And to do this, I just made a set from 1 to n, like describing which numbers are not inserted yet. Like I'll just show you the code, or I'll just explain here once. That initially I made a set from 1 to n. Then I iterated over the array. I goes from 0 to n minus 1. And I checked a of I. So if a of I is in this set, then that means that it hasn't been used yet. So I'll just use that, like b of I will make as a of I. And then I'll erase a of I from the set. Set dot erase a of I. Otherwise, I'll just insert any element from the set. Like else, I'll just set bi to any element in the set. I'll just choose the first element, star s dot set dot begin. And then I just erased s, sorry. Then I just erased set dot begin. Set dot erase. All right. So this is what I did. So does anyone have any doubt in this? I'll just see the chat. Aditya, your doubt, like you are asking that if we had been given all the elements from like the element limit was from 1 to 9 and the mode array was also from 1 to 9, then I think that is a very different question. um, it is a good question to think upon, but I will not be able to answer that right now because I'll have to think on it. All right, so any other questions? What is the intuition behind this? That I just observed, like it is an observation. It's an observation that the definition of the mode is very it is very loose, right? So therefore I can do this since it is very loose. And observation here is that any number can be in the mode in an array which consists only of unique elements. That is an observation here, and using that we can solve the problem. uh, okay, please show the code. Sorry, also can you tell about the minimum one where you said there will be distinct answers? Okay, so like that was like I was just proving that why this definition is like why this is um like not tight. That was not very important actually, so I'll just skip it. Okay, I'll just show you the code. So I just took the input. This ia means input the array, like this is my macro. I made a set, and for I from 0 to n minus 1 I inserted, so this set has 1 to n. Now I iterated over the elements of ai, and if the set has ai, then I printed ai and erased ai from the set. Otherwise I just printed the first element from the set and erased the first element from the set. All right. Okay, like what I had said was this definition is not tight. That means like actually I had just given an example that why it is not tight, because there are multiple answers. Like if the definition was that the mode, suppose definition was mode is the element with maximum frequency and minimum value. Like if we were given this, then my solution is not right, because in this case the definition is like very tight, that there is only one answer for the mode. That's what I was saying. Like I don't know if this is solvable or not. I just give an example. Like I don't. You should think. You can think on it, but I don't know if it is solvable or not. Okay. Anyways, so shall I go on to the problem E?
But I had a doubt actually.
Okay, go
But
on.
I wrote the code in the contest, like I got the intuition, but I
Hmm.
got time limit exceeded again and again. I have just shared the code in the chat. Can you just tell me why TLE came?
Actually, you can ask that in the doubt section of TLE.
Okay.
Yeah. Okay. Let's move on to problem E. Insane problem. Okay. Wave is given five integers k, L1, R1, L2, and R2. Wave wants you to help her count the number of ordered pairs such that all of the following are satisfied. L1 less than equal to x less than R1, L2 less than equal to y less than equal to R2. That is, we have to find x and y, and such that y upon x is some power of k. Like we have been given k, and we want to find the number of elements which are in this range, which are some power of k. Okay. So like for example, let's say we can take the third test case, 3, 5, 7, 15, and 63. So in this case, 3 k is equal to 3. uh, can you mute your mic, everyone? Okay, so k equals to 3 in this case, and the interval is 5 comma 7 and 15 comma 63. So this is the interval for x, and this is for y, and we want y upon x to be some power of 3, and where n can be 0 as well. All right. So the thing to notice here is, first of all, y is a multiple of x. I think that is pretty clear. Y is equal to x into something. So y is a multiple of x. That is one thing. Let's say in this case we want to count. So how will we count? If x equal to 5, then what we can have? Then y can be a multiple of 5, like 5 into 3 to the n. So 15, because it is in this range. Or we can have 45. Then let's say x equals to 6. Then y can be 6 into 3, that is 18, or 6 into 3 square, that is 54. And if x equals to 7, then we can have y equal to let's say 7 into 3, 21, and 63. So all of these y's are in this range of y. Therefore, all of these ordered pairs are correct. So therefore, we have the answer as 6, right? So actually, what you can see, like as you can see that I iterated over the range of x, right? I just iterated from 5 to 7, and over the values of n. I did 2 iterations, and then I checked if the value of y was in the range or not. So if I just write a code to do this, then it will give TLE. Why? Because the limits are very harsh. That x is from L1 to R1, but L1 and R1 can range from 1 to 109, right? So therefore, I can't do this. It is a brute force approach. I can't do that, right? So let's look at the constraints. The constraint said that k can range from 2 to 109, L1 and R1 are from 1 to 109, and same for L2 and R2. Okay, now I'll think about what can I iterate over. Like, um, I don't think it is possible in O of 1. Like, you are just given the values of L1, R1, L2, R2, and K, and you just make a formula. Like you make a formula and print it. I don't think that is possible. Like intuitively, it should not be possible. It is a complex problem. Can you? Yeah. So the problem is very complex. So I don't think it can be done in O1. So what I thought next was, what can I iterate over? I can't iterate over X because it ranges from L1 to R1. Same for Y. I can't iterate over Y. But what I can iterate over is N. Why? I'll explain. Like Y upon X is K to the N, right? Y upon X is equal to K to the power of N. Now, the thing is that where can this lie? I'm asking what is the maximum possible value of this? Max value of Y is 1 in 9 and min value of X is 1. So if we divide, we'll get 1 in 9. So in the worst case, this value can be 1 in 9. So what we can see that K to the power N in the worst case can be 1 in 9. So in the worst case, N can be log 1 in 9 to the base K. Do you get this? Everyone? Yes? Please repeat. Okay. So I was saying that I can't iterate over X because the limits are harsh. I can't iterate over Y. But I then checked for N. Wait, just a minute. Yeah, so I checked for N, and then I saw that Y upon X equals K to the power N, right? So now I'm thinking that how much can this go, Y upon X? So the answer is like max value of Y upon min value of X. That would be the case where this would be maximum. So what can that be? That is 1 in 9 upon 1, which is 1 in 9. So at max, this value can go up to 1 in 9. So therefore, that means this can go up to 1 in 9. So K to the power N can be at max 1 in 9. So like as we increase N, this is exponential, right? This is like K to the power of X, and we are increasing X. Like not this X, this is different. Like we are increasing X, so K to the power X would be exponentially increasing. So it would not be very late, like it would be very soon that it reaches this value. Like for example, if K is 2, then 2 to the power N, as we grow N, like suppose N is 30, then 2 to the power 30 already crosses 1 in 9. So there are not many values for N that we need to check, right? N can only go up to log 1 in 9. uh, can you understand this? Do you get it? Yes. Okay. So basically we can iterate on N. N goes from 0 to log 1 in 9 to the base K. Or we can say that we'll just take a multiplier, like we'll just iterate on the K to the N. We have K to the N. So we'll keep a variable P which is set to 1 initially, and after every iteration I multiply it by K. P multiply equals, sorry, P multiply equals K, and we do this until P is less than or equal to 1 in 9. All right, and we can do it because it is log of 1 in 9 time, right? So this is clear. Now if I have the value of P, then what do I do with it? That is the question. So let's say we have the value of p. P is what? I had defined p to be k to the power n, right? So we want our y by x to be k to the power n, which means y by x is equal to p, right? Which means that uh, y equals px, right? That is the equation. And now we want this y to be in between L2 and R2, right? We want L2 less than or equal to y less than or equal to R2. So I can say that L2 is less than or equal to px less than or equal to R2, right? So now I can say that L2 by p is less than or equal to x less than or equal to R2 by p. Like in this case, I am not taking integer division. This is normal division, like the floating point one. This is not yet integer division, right? So I can say this. But x is an integer. So actually I can make this even tighter. Because I know that x is an integer, I can take the ceiling of here and the floor of here. This is a very common trick that like I just explained that if I want x to be greater than or equal to L2 by p, you know, like this is what is written here. I want this. So let's say this is the number line 1, 2, 3, 4, 5, 6. These are integers. Let's say that L2 by p is somewhere here. So I want x to be greater than or equal to L2 by p. So I can say that it is this range from 4 to 4 and above, because x is integer. So it cannot be like these values. That's why I took ceiling. If L by p was here, then it would be 5 to 5 and above. Do you get this, everyone? Yes, okay. And like for the second one, this is the first one, right? I explained the first one. And for the second one, we want x to be less than or equal to R2 by p. X to be less than or equal to R2 by p. So let's say that R2 by p is somewhere where it is. And just show. Suppose it is here. Then the range is this. But x is an integer. So the range is actually this. And this is the GIF of the point, right? So x is less than or equal to GIF of R2 by p. I hope it is clear. No, taking floor for both won't work. That is because I'll explain. Let's say basically x greater than equal to L2 by p, right? So let's say L2 by p lies somewhere. L2 by p is here. So our range is this, right? But if you take floor, then you say that the range is this. So you are taking this extra value, right? Therefore, floor is wrong. You can't take floor in this case. If you want greater, then you will take seal, and if you want less, then you will take floor. That's the thing, right? Got it. Okay. So basically, what we are left with is this. I'll just copy it one more time. Seal of L2 by P is less than or equal to X is less than or equal to floor of R2, right? So basically what we have is a range for X. Like from the condition that Y is from y belongs to L2 to R2, we got this condition, right? But we also have another condition for x, that x should belong to L1 to R1, right? So we have one interval for x here and one for x here, and we want both of them to be true. Therefore, we just take the intersection of both these intervals. This interval and this interval, we take the intersection. And I think how to take the intersection is simple. I think like we'll take the max of both the L values, L2 by P, comma L1, and we'll take the min of our values. I think this is very well known. R2 by P, comma R1. Is there anyone who doesn't understand this? Okay. And also there's one trick for taking the ceiling. Like here we have to take the seal, right? L2 by P, seal. We want to find this. Like by default, if you do x by y in C++, then it will give you the floor of x by y. I mean, not the floor. For positive numbers, it will give the floor. So we can get this easily. But to get this, the trick here is that we can just do L2 plus P minus 1 divided by P. Like this will give you the ceiling. This is a nice trick that you can use. Okay, right? So yeah, now like so now what we have is for certain value of n, we have k to the power n as p. So for certain value of p, we have found the number of pairs. Like basically after taking the intersection, we'll get this, right? So the number of numbers that are in this interval, that is our number of pairs. That is clear, I think. So for certain p, we got these number of pairs. Like number of pairs would be this minus this plus 1. You know, like because the number of numbers in that interval is this. Like the number of numbers from L comma R, that is like R minus L plus 1. Na? So for certain value of p, we got this answer. And we just iterate for all the value of p and add up to get a final answer. I explain this trick for getting the ceiling. Okay. So what we want is ceiling of L2 by P. Can you mute yourself? Okay. We want the ceiling of L2 by P. Right. So let's say that L2 any trick like so let's say that L2 is divisible by P. If L2 is divisible by P, L2 mod P equals to 0, then the ceiling should be just normal value of L2 by P. Like L2 by P, the ceiling would be equal to just L2 by P, right? Now let's say that is not equal. If it is not equal to 0, like let's say the number line here is this, L2 by P, the GI of L2 by P is here, and L2 by P itself is somewhere ahead, which means that L2 leaves a remainder when we divide it with P. Is that understood? Like if the value of L2 by P is here and this GIF is here, that means that the remainder is something while dividing it by P. So if that is the case, then we want this value, L2 by P plus 1, right? So that's a trick. Like what I told you was L2 plus P minus 1 upon P. Now let's say that L2 doesn't have any p. Like after dividing it with p, we get remainder 0. Then this p minus 1 won't change anything because anyways it is taking floor. Like for example, if I say that 6 plus 2 upon 3 GIF, then this 2 is just contributing to like 2 by 3. I mean, this is 8 by 3, right? 8 by 3 ka floor, and which is 2. So this 2 won't change anything because the remainder is 0. But suppose it was 8 by 3 ka ceiling. We wanted to find this. Then what would we write it? We would write it as 8 plus 2 upon 3 ka floor. So now this 2 has made, like, I'm asking that what is 8 by 3? 8 by 3 is 6 GIF and ceiling is 9. So now what the 2 has done is that this value is now, sorry, 8 by 3 ka ceiling is 3 and 8 by 3 ka floor is 2, and if you multiply it by 3, then you get 6 and 9. So what this plus 2 has done is that now this value is greater than or equal to 9. Like plus 2 had made it greater than 9. So therefore if we divide it by 3 and take the GIF, we get 3. And like if it was 6, initially it was 6, so the plus 2 couldn't do anything because 9 tak nahi pahuncha paya. So it only reached till 8. So therefore 8 by 3 is still 2. That's how it works. Okay. Or just use floor function and seal function. That can sometimes give wrong answer because that is actually defined for floating point numbers. In C++, the functions floor, sorry, uh, the functions of floor and seal both are defined for floating point functions, floating point numbers, and sometimes in floats, some error can happen, like the precision error can happen. So but it's better to use it like this. For integers, it's better to use this L2 plus b minus 1 upon p. All right. Okay. Just a second. Yeah. So till now, what we have done, we have for some value of n, we have p equals k to the. Can you mute? Sorry. Yeah, we have p equals k to the n, and for every p, we have calculated the answer, and we'll just take the sum of all the answers. One thing to take care of is that uh, when you are doing this, like the intersection of that, this is just messy. Wait a minute. Yeah, so one thing to note is that when you are when you are doing this, then you have to check that the max of this, like let's say I have two intervals L1 comma R1 and L2 comma R2. What I did was max L1 comma L2 and min of R1 comma R2. But here I have to check that they should satisfy. Like the right limit should be greater than or equal to the left limit. If that is not the case, then that means that these two intervals have no intersection. Like if the intervals are like this, L1 R1, L2 R2, then they won't have any intersection. So in that case, we will add 0 to our answer, and otherwise we'll just add the length of this interval. Right? I hope it is clear. Okay, I'll just show the code.
Okay.
Yeah, so the code is very simple. I just took the input k, L1, R1, L2, R2. Then I set the parameter u. Actually, I took u instead of p. U equals 1, answer equals 0. Like I am adding the answer. Then while u is less than equal to 189, I am just adding the like min of R2 by u comma R1 minus max of L2 plus u minus 1 by u. This is like this comes from y and this is from x. I take the max of it, and this one comes from y and this is from x. I take the min of it. So basically this is the r value, this is the l value, and I sorry this is the l value, the whole thing, and I just did r minus l plus 1, and if it is negative then I need to add 0. So I just took max with 0 and I added it into the answer and then multiply by k, right? Okay, so any doubts for this? If we multiply it by 1.0, will it become double? Yeah, it will become double, but again, storing doubles is like not precise. Like it is not accurate. Like basically, it is like you cannot store floats and doubles exactly. It stores just the approximate value. So it is not recommended that you use float or double while handling integers. What is the expected rating for this problem? I don't know. You can check CList. If anyone has other approaches, then like I haven't thought about them, so like you can ask them in doubts. CList is a website where you can check the ratings for the problems. CList.com. Okay, I'll just move on to the next question, which is F, right? Easy D1 problem. Okay, just 1 second, guys. Okay, so it says for an arbitrary grid, robot defines its duty to be the sum of elements in the grid. Okay, the beauty of a grid is sum of elements of the grid. Then robot gives you an array A of length n and an array B of length m. You construct a n by m grid such that mij is equal to ai into bj. Okay, so you are given two arrays a and b, and you construct this grid such that mij equals ai into bj. Okay, then the robot gives you q queries, each consisting of a single integer x. For each query, determine whether or not it is possible to perform the following operation exactly once, such that I have a view of x. Like um, it gives you q queries, and in each query it gives an x, and basically we can perform an operation. We can choose two integers r and c and set mi to be 0 if I equals to r or j equals to c. Like in the rth row and the cth column, we set all the values to be 0. Originally they could be something else, but now we set them to be 0. And we have to figure out that is it possible to make the sum equal to x. Like basically we have been given a matrix, right? uh, let's say this is the matrix. The beauty is defined to be the sum, right? And in one operation we can choose any row. Suppose I choose this row and any column, suppose this, and I'll make all the elements inside that row and column to be 0. Like whatever they were previously, I'll just make them 0. So we can do this operation, and uh, we have to figure out that can I find some r comma c such that doing that operation results in the beauty equal to x. Like the remaining elements ka sum should be equal to x. So is there any way to do that? I have to find that out. All right. So actually, this is a very good problem. I liked it. It like it is a combination of many different topics. So, anyways, um, so here we can observe certain things. The limits of nm and x, like nm and q are up to 2e5, n and m are up to 2e5, q is up to 5e4, and the values are up to values of a are up to n, values of b are up to m. And the interesting thing here is that the value of x is up to 2e5. Like x is a number, right? It is just a sum. So it could have been up to 109 as well. But for some reason, they took it to be only 2e5. So why would they do that? And also the time limit is 4 seconds, which is a pretty generous. Like it is something unusual, right? So uh, what we can think about is like, yeah, how I did it is that I calculated that for some LNR, what would be the effect? Like, for example, if the array is A1, A2 up to AN, and the array B is B1, B2 up to BM. So the matrix that would be uh, A1, B1, A1, B2 up to A1, BM, then A2, B1, A2, B2 up to A2, BM. And we can continue this like that, and it will be an b1 up to an bn, right? So initially, if I ask you what is the beauty of this matrix, like before removing any elements, what is the beauty of this, then I can easily find out. Like suppose if I take the sum of this row, then it would be a1 b1 plus a2 b1, sorry, a2 b1 plus up to an b1. So we can write this as b1 into summation of ai. I just took b1 out common, and it became b1 into sum of ai, right? And like for all rows, I can do this, or for all columns, I mean. So for all columns, like for the ith column or for the jth column, the sum would be bj into summation of ai. And this summation of ai is just a constant value, right? Like the sum of all elements in ai. So I can write this as bj into sum of, let's say this is capital A. Sum of a is capital A. Okay. So this is sum of jth column. So the beauty would be sum of all columns. Sum of all columns, right? So this is that would be the sum of bj into a. All right. So we can take a out because it doesn't depend on j. So it is bj, and this is like the sum of elements in b. So it becomes a into b. So like, is it clear up till here? Yeah, sum of a into sum of b. Uh, you cannot do brute force by checking possible R and C, because like selecting one and checking for the other. I have not done like that, so I don't know right now. So I'll just, yeah. So anyone, does everyone get this? Any doubt in this? Like how did this A into B come? Okay, so now what I want to see is, let's say I choose some column and some row. Let's say I choose the row R and some column C. Then what would be the effect of that? Okay, so here like A11, sorry, A11, I mean A1 into B1, A2 into B2, sorry, A1 into B2 up to AN, A1 into BN, and similarly you can fill all the elements. So as you can see that if we um, make all the elements in row R to be 0, then this whole row would be 0 and this whole column would be 0. I have drawn it some tilted, but you can assume that it is straight. So that whole row and whole column would be straight. So if I ask you that what is the sum of the remaining elements, like what is the new beauty that you get, then how do you answer that? You can basically, what you can do is take the original beauty, then subtract the sum of this row, initial sum, subtract the sum of this column, and add this element's value, because you counted it twice, right? So this would be just A into B minus sum of the elements in the rth row. So in the rth row, it is AR into some BJ, right? So sum of elements would be AR into sum of B, AR into sum of B, minus in the Cth column, the elements are some AI into BC. So the sum would be BC into sum of elements in A and plus this element. Like I said, we have to add this element. So it becomes plus AR into BC. So is there anyone who didn't get this? Yeah, O of NM won't pass actually, but this is like I'm trying to build the intuition. O of NM won't pass. So does everyone get this? That the the remaining sum would be this. Any doubt? Got it? So I can write this as A minus AR into B minus BR. है ना? Like, does anyone, like, we can write this, sorry, B minus BC, I mean, B minus BC, we can write this A minus AR into B minus BC, right? So this is observation. Like, the sum, if we choose the row R and a column C, then the new sum is A minus AR into B minus BC, which is same as like if A didn't have, the array didn't have this value and the array B didn't have this value, then the matrix that would have been made, uska value is the value. Like, you can also think of it like this, that we are deleting this row and this column. So essentially, we have deleted this row's element from A, which is AR, and we have deleted this column's value from B, which is BC. So all the remaining elements are there. These elements, like all those elements are still there. So if the array didn't have AR originally, then its sum would be A minus AR. And if it didn't have the BC, then its sum would be B minus BC. If the array B didn't have this. So the matrix the sum of that matrix, like the beauty, that would be its multiplication. So that's also another way to think about it, right? So yeah, that's what we have reached up to. Now, the queries. In the queries, we have been given x, and we have to figure out whether we can choose such RNC such that um, the x is equal to a minus ar, b minus bc. Like, do you agree that the problem boils down to this? We have to find such RNC such that a minus ar into b minus bc is equal to x, right? Okay. Please repeat the last step. Last step, which is factorization, like here to here. So like I just took b out from first these two terms and minus bc out from these two terms. So I get a minus ar into b minus bc. Yeah, so x is equal to this, and also you can observe that this is integer because all ar are integer and sum is integer, and this is also an integer. So basically what my point is, that we have to break this x into two factors and then find out whether that factor is in a and this is in b or not. Like, what I can do is, for all r from 1 to n, I can make an array of a minus ar. Like, I'll take the sum of a and make an array of a minus ar, and then I just factorize x and check if that element is in this array or not, and if the other element is in this element. So, like, for example, if I wrote x equals to y into z, then I'll just check whether y is present in a and whether z is in b. If we find such y and z, then we can say that yes, we'll just choose that r and that c, and we'll get the answer of x. So we'll just print out yes. So now it boils down to the problem of factorization. We just need to factorize x into two factors, right? And you can do that in O of root x, O of square root of x. Like, you can just iterate over, you can iterate from 1 to square root of x, and then what you will end up is with one factor. Like, if x equals yz, then either of these two factors will be less than root x. So this is one factor. Suppose it is p, like, or it is y, let's say. Then z would be just x by y. So you will have these two factors, and then you can just check whether y is in array A, I mean this array, and whether z is in the array of b minus br or b minus bc or not. All right, but also you need to check whether like, there are, you have to have casework, like if x equals root y and z equals x by y. But it can also happen that root, like, this y value is not in a and this value is not in b, but it can happen that this y value is in b and this x by y value, it is in a. So it can happen like that also. So I have to check that also. And x can be positive. Suppose x is positive, then either I can take my y and x by y, or I can take minus y and minus x by y, right? I can do that also, because inca product will also be positive, like x. So I have to search for this also. So basically, I have to search for four things. Suppose I am iterating over 1 to root x. Then I have to check for, let's say, z equal to x by y. Then I have to check in a and b. I have to check for y and z, z and y, minus y minus z, and minus z minus y. So out of these four, if any one is present in the array, then I can just say that yes, I can make the x. And this is for x greater than 0. Like, this is for x positive. If x is negative, then you have to choose one negative, one positive. So it will become uh, sorry, minus y z, or minus z y, or let's say y minus z, or uh, z and minus y. So this is basically casework. So like, you will check these numbers, and checking will take, like, you can use binary search to do that. Like, um, first of all, you will make the array of a minus ar for all r, or like I can say a minus ai. You will make this array, and then you will sort it. So you have a sorted array, and you can check whether the element is in here or not. That will take O of log n time using binary search. So finally, what we are doing is, every query what we are doing is, we are breaking x into y and z. This takes O of root x time. Then what we are doing, we are checking for y in a and z in b. And checking takes O of log n time. So this will take O of log n plus log m time. So for query, we are answering in O of root x into log n plus log m time, right? This is the TC per query, and this should pass, like, basically total time complexity will be O of q into this, and this should pass because q is like 5e4 and x is 2e5. So root x will be like, I guess, 500 or something, 500, around 500, and q into root x into log is like negligible, or like we can say that it is still 20. 20 plus 20, which is 40. Root x is up to, let's say, 250, and q is still 4, sorry, 5e4. So this should pass because
एक मिनट में।
the time limit is like 4 seconds. This will turn out to be 25 into 20 is 500,000. So this is 5e7. It should pass comfortably. Okay, x equals to y into z in O of root x. How to do that? Okay, so I'll just explain that how to do that. X equals yz. What does this mean? That we are breaking x into factors of y and z. What I am saying is, either one of these factors will be less than or equal to root x. Like either y or z is less than or equal to root x. Can you see why that is? Yes. So I'll just iterate over y from 1 to root x, and I'll check if y is a factor of x. Like if x mod y equals 0, then y is a factor of x. So the other factor of x would be x by y. X by y is z. So therefore I got y and z. I'll get all the possibilities of y and z in O of root x time. Understood? So any doubt? Anyone else? Okay. So yeah, I think the logic is clear. I'll just show the code. So first of all, I found the sum A, like this is the sum function accumulate. I found the sum A, sum B, and like I am keeping this vector of A minus AI. I am pushing the values of A minus AI into this and B minus BI into SB. Then I'm sorting them so that I can easily find out whether a value is in SA and SB or not. And this is a function like I have written to reduce the implementation. It is like this fnd function. It just checks if like p and it checks if p is in A and q is in B or not. So how does it do that? Like given p and q, it finds a lower bound of p, and if that is equal to p, then p is in A, and if the lower bound of q, if the lower bound of q is in SB, like if it is equal to q, then q is in SB. So I'll just take the and return the and, right? So that's how it finds whether an element is in an array or not. Now for the query, I input the x and flag equals false. This flag is that whenever I find a factor, then I'll just set this flag to true and then I'll break. And if in the end, if flag equals false, then I'll print no. And if flag equals true, then I'll print yes. So uh, that's what the flag is. So sign is x greater than equal to 0, which means that is x positive or negative. If x is positive, then sign will be like true. Okay. Then I iterate over the factors of x. Like I do this, I start from 1 and I stop at root x. Like I into I is less than equal to x. Now if x mod I equals 0, that means I is a factor. Therefore, x by I is a factor. So like p and q are my factors. Now I have two cases. Like if it is positive, then I can either have p comma q or minus p comma minus q. Like if either of these two combinations are there in the array, then I'll just set the flag as true. And if it is negative, then either it is minus p comma q or p comma minus q. So if it is true, then I'll break. Like if it is found, then I'll set the flag and then break. But it is possible that I is in B and x by I is in A. So I just swap P and Q and uh, the same thing. Like I just copy pasted this here to here. And if any of these four things are true, then the flag will become true and then I'll break. Like this break isn't necessary, but it will optimize your code. And then if I found the flag, then I'll just print yes, otherwise I'll print no. Any doubt in this? Anyone in doubt? Okay, I'm assuming no. So this was the problem, and we solved it in like this complexity. O of like initialize, we have to do in n log n for sorting. N log n plus m log n plus per query, we are doing root x work and like log n plus log n to find out whether there exists or not. All right. Can I show the for loop? Okay. This is the for loop. All right. So let's move on to the next problem, which is G1. And it is actually a very interesting problem, in my opinion, both the easy and hard versions. Okay. So basically, the problem says that a group of n spiders has come together to exchange plushies. Plushie is an object, I don't know. Initially, each spider has one plushie. Every year, if spider I has at least one plushie, he will give exactly one plushie to spider I. So we have been given an array R, and every year the spiders give away one plushie if he has one. Otherwise, he'll do nothing. Note that all plushie transfers happen at the same time. In this version, if any spider has more than one plushie, then they will throw all but one away. Like, for example, if two spiders gave the same person a plushie, then he will throw one of them, and like he'll only keep one of them. That is the thing in this version. The process is stable in the current year if each spider has the same number of plushies as he did the previous year. Note that year one can never be stable. So find the first year in which the process becomes stable. Okay. So the problem says that we have some spiders. Let's say, just a minute. Okay, yeah. So this is one spider, two spider, three spider. Suppose one spider gives to two spider, second one gives to third, and third one to second. So initially they all have one plushies. Now in the next year, this one will give to this one will give to this one will give to this. So these cancel out, and this one will give to this. So basically, after the first year, what we have is something like this. He will have 0, he will have 2, he will have 1. But since he has 2, he will throw 1 away. Right? That is the problem. That if he has more than 1, then he will just throw out 1, so it becomes 1. Now in the next year, this one is like he doesn't have anything to give, so he won't give. And these two, like this one will give to this one, and this will give to this. So it will be the same thing, 0, 1, and 1. So since after the exchange it is same, we are saying that it is stable. This is stable, right? So in this case, the answer would be 3, I think, if I'm not wrong. Yeah, the answer would be 3. So that is the problem, that we have to figure out what is the first year after which the it is stable, right? So it is actually a very good problem, that we are given an array of the connections. Like spider 1, spider 2 ko dega, then spider 2 will give to spider 3, and so on, like the array. So what this is, we can actually think of it as a graph where spiders are not like I did that only. Like here, this is a graph technically. So we have n nodes, which are n spiders. Suppose we have 5 spiders. Then from each node, we have one outgoing edge. That is, which spider will this one give to? So like suppose this is the first spider, this is second spider. Suppose this is the graph. Suppose it is like this: 1, 2, 3, 4, 5. So like this will have the input of 1 will give to 2, 2 will give to 3, 3 will give to 1, and 1 and 1, right? So like for this input, we can make this graph which corresponds to this input, right? Like it is a very nice way to see, to visualize. Like making it a graph, it is like it makes the problem simpler actually. So I'll use this graph to solve the problem. Okay. So initially, all the vertices have one. All the vertices have one candy. Like okay, I'll just call them candies. right? So initially all of them have one candy. So one, 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 one. Now after, like, so basically everyone is alive right now. Let's say everyone is alive at this point in time. Now, what will happen after the first year? These two will give their plushie to one, right? But no one is there to give them a plushie, right? Because the in degree of both of these nodes is 0. So no one is there to give them their plushie. So therefore they will die. And but the rest of these don't die. Like they are alive because someone gives them a plushie. That is thing. Like after the first year, these two die, and it remains like uh, one, one, and one, right? Because actually, these two gave a plushie to one, and this one also gave a plushie to one. So one would have three plushies. But in this version, one just throws out all those three plushies and is left with just one. So this is the configuration, and as you can see, it is stable because this one will give to this one, this one will give to this one, this will give to this. Like as you can see, it is stable, right? No one will die. Everyone will be staying alive. Only those two who did not have any in degree, those two died, right? Now let's take another example. Let's say we have this a cycle of this length. It's a 4 length, and let's say this, this. All right. So the thing is that after the first year, these two will give the plushie to this one, but no one is there to give a plushie to them. So they will die, right? And also this one will die because of integer 0. So now it will become like this. After the first year, it becomes like this, and right now this one will give to that, but no one is here to give to him, right? Because the one who was there, like they died. These two nodes did give to him, but they died. So therefore, now no one will give to him. So in this iteration, he will die. So finally, what we are left with is this, and it's a cycle. Like finally, as you can see, only a cycle can sustain itself. If there are nodes which are like not in the cycle, somewhat like this, then eventually they will die. First, this one will die, so these two will die, and then this will die. So we just need to figure out that what is the first moment at which these nodes die. Like all of the non-cycle nodes, how much time will it take to die? That's what the problem boils down to. All right. So how do we solve that? So basically, it is kind of similar to topological sorting. Like, but there could be multiple cycles. Multiple cycles, yeah, there could be. But as you can see that the out degree of a node, out degree of I is always one. That's the constraint in this problem. So um, it cannot happen like this. Like the same component can't have multiple cycles. The thing is that like it can't happen like this because for this node will have two out degree, right? So what I'm saying is that each component will have just one cycle, and every like some nodes will be in that cycle and some won't be, and the ones who aren't, we just need to check like when will they die, right? I hope it is clear. So how do we check that? So it is very simple actually. Let's say we have this graph. Sorry. So let's say we have this graph, and I want to figure out when will the non-cycle nodes die. So what I can do is I can check which nodes have in degree 0. So this and this, and I just delete them in the first iteration. So I will keep a counter here. Initially count equals to 0. In the iteration 1, I delete them, so the count becomes 1. Now, so now what it is like, it's like this, right? So while deleting those nodes, I'll just decrease the in degree of this node, and I'll see that the in degree of this node has become 0. So therefore, in second iteration, I can delete this node and count will become 2. So it will become like this. And then after that, I can see that there are no nodes with in degree 1, with in degree 0. So count equals to 2, which means fourth here is my answer. Yeah, something like Kahn's algorithm. Uh, is it necessary that there will be a cycle? Yeah, there will be a cycle, because like suppose there is no cycle. Um, suppose you are saying that cycle नहीं है. So how can that be? Suppose अगर ना हो तो फिर this node won't have any out degree, right? Everyone should have out degree. Therefore, there has to be a cycle. Yes, there can be two cycles, but they can't be connected. Like it can happen like this. Let's say one cycle is this, and then one is this, but they can't be connected because each node has out degree 1. Unlike there can be other nodes who are not in the cycle, like this. It will be a tree because cycle nahi hai. All right. Actually, they are called functional graphs. These kind of graphs where there is only out degree 1. Like for each node, if the out degree is 1, then it is called a functional graph, right? And the property is that in every connected component of this functional graph, um, there is only one cycle, and other ones are trees of the nodes. Other are other are trees. That's what the property says. That in for every functional graph, cycle is there, and other are trees. Like for some nodes, there may be trees, but cycle only one can be there in each connected component. There can't be two cycles who are connected. This can't be the condition. So what we are doing is just simply like Kahn's algorithm, that if in degree is 0, if in degree of I is equal to 0, then we will just delete that I. And while deleting that I, we will also reduce the in degree of its parent, like of the child actually, like R of I, we will reduce the in degree of R of I minus minus, and then we'll just check whether its in degree is 0 or not. If in degree of R of I equal to 0, Like if this is the case, then we'll just push it into a queue. Q dot push R of I, and we can just check how many times we have to iterate. We can count that, and we'll just print count plus 2, right? And that's the answer. So I'll just write in this. For example, for this test case, 41154. Uh, let's say 1 gives to 4, 2 gives to 1, 3 gives to 1, 4115, 4 gives to 5, and 5 gives to 4. So in this case, first 2 and 3 will be deleted. So count will become 1. Then 1 will be deleted. So count will become 2. And then there are no nodes with degrees 0. So therefore 2 plus 2, which is the 2 plus 2, which is 4, that is the answer. So therefore 4 is the answer. Right? That's what we are doing. So I think it should be clear. And also in each iteration, we are deleting at least one node. Like we are doing this until there are no nodes with degree 0. And in each iteration, we are deleting the nodes with degree 0. So my point is that in every iteration, we are deleting at least one node. So there can't be more than n iterations. Right? Actually, more than n minus 1 means like n can't be also there, because in each we are deleting one node, at least one node. So in the end, we will be left with like at least, like we can't have an iteration. That's my point. So therefore, it won't give TLE because it is of n basically. What if there is a node 6 with 1 in this graph? Okay, so let's say there was a node 6. So in that case, 6, 2, and 3, all of them would be deleted in the first iteration. After that, 1 would be deleted. So the answer would be 2 plus 2, which is 4. So they would add 3 to 1. Yeah, they would give 3 candies to 1, but 1 will throw 2 away. Like basically 6 would die, and like these 3 would die, and then 1 would die in the next one. So like I don't. So now cancel that 3 out. Won't it take 3 more years to make it 0? No, actually in this version, 1 throws out the candies. Like it is written here that in this version, if any spider has more than one plushie at any point in time, they will throw all but one away. We are solving G1 right now. In G2, what you say is correct. That if uh, there are 3 candies, then one will have 3, and it will take 3 more years to like give away. But in this version, only one will be remaining. Yeah, okay. So I think that's understandable. Any doubt? I'll okay. Why we did 2 plus 2 here? Yeah, actually, because let's say you have this 1, 2, 3. So the answer in this case count would be 0, because there are no integer node with there are no nodes with integer 0. But the answer to this would be 2, because year 1 can't be stable, and in year 2, like in year 2, the configuration is same as year 1. So like the stability is defined as this, that the process is stable in the current year if each spider has the same number of plushies before the year exchange as he did the previous year. Like in the year 2 it is this, and in the year 1 also it is this. Therefore the answer is 2, but count is 0. So we'll just add 2 to the count, right? This is why we add 2. I hope it is clear. Okay, so now I'll just show you the code. I take the input and make it 0 indexed, right? AI minus minus. Then I just count the in degree. I iterate over the array and in degree of AI plus plus. Okay. Now, if in degree of some vertex is 0, then I push into a vector v and count is equal to 0. While v dot size, like if there are some vertices in v, that means they have in degree 0. So I will delete them. I have a vector u in which I'll just add those vertices which have become in degree 0 right now. Like I'll iterate over all the vertices in v and I'll delete them, which means that I will decrease the in degree of their child by 1. And if their in degree becomes 0, then I will just push back into this vector, that vertex. And then I'll just do swap uv. I mean, that is the same as u equals v in this case, and count plus plus. So like all the vertices in this u will go in this v, and the loop continues like that, and count plus plus, and we will just output count plus 2. I hope it is clear. Okay. So let's go to G2. Like my implementation here is very nice, but as you will see in G2, it is as bad as it could be. Okay. So let's go to that. In G2, the difference is that if a node has more than one candy, he won't throw it away. He'll keep it. Okay. So like for example, in this test case, we had 4 1 and 5 4. So we had a graph like this. 1 gives to 4, 2 gives to 1, 3 gives to 1, 4 gives to 5, and 5 gives to 4, right? So after the first iteration, 2 and 3 will give to 1, and 1 will give to 4. So 1 will have 2 candies. 4 will have 2 candies because 1 gave it 1, and 5 gave it 1, but it gave 1 to 5, right? And 5 will have 1. Like finally, this will occur after the first year. After the first year, this will be the case. One will have 2, 4 will have 2, 5 will have 1, right? Then after the second year, no one is there to give to 1. So 1 will be left with 1 because it gives 1 to 4. 4 will have 3, and 5 will have 1. Then in next year, this 1 goes to 4. So we are left with 4 gives to 5, 5 gives to 4, and 4 has 1. Sorry, 4 has 4, and 5 has 1. So this condition is stable because it is a cycle. As we could see in the previous one, like if there is only a cycle or multiple cycles, like if all nodes are in a cycle, then it is stable because 4 will give 1 to 5, and 5 will give 1 back to 4 in each year. So the configuration won't change. So that's the thing. In this, the difference is that 1 doesn't die immediately. Like in this case, 2 and 3 died. Then 1 was left with 2 candies. So therefore, it didn't die immediately. It took one more iteration for it to die. For it to die, it took one more iteration. So like it became 1, and then it died. The difference is that. So how do we solve it? Actually, it is a very good problem. So first of all, the observation here is that the cycles won't die ever. Like, of course, like any node in a cycle, it will always have an input. Like, I think it is pretty clear that the cycles won't die. And the nodes not in a cycle will always die after some time. Like, after enough time, the ones not in a cycle will die, right? For example, in this case, these four are in a cycle, so they will never die, and these two will die after some time. After like year one, they will die in this case. So let's say that dp of v denotes the year after which they die. Like, or let's say the dp of v denotes the number of years v was alive. Like, I am defining that. Like, why am I doing that? Because let's say I have some things. Let's say there is this thing cycle here. This is a cycle. Then there is a node which points to a cycle. Then there are like two children of this. There are some children of this as well. Suppose there is this one here as well. Right? So what I am thinking is, when will this node die? When will this node die? It will die once it runs out of candies, right? And when will that happen? Basically, what you can see is every year, if not every year, like every year, one candy is being given away to the cycle. But every year, the number of children of it who are alive, he will get those number of candies from the children. So minus one plus number of alive children. That's the thing. Every year this happens. So if you see that, if you like ask me that over all the years, what is the sum? Like, every year minus one happens, and number of alive childs, all of them give it a candy. So for example, let's say this child, let's say it has three children. Wait, this is a node, okay? Uh, wait. Yeah, so this is a node V, and these are X, Y, and Z. So if I tell you that X was alive for capital X years, Y was alive for capital Y years, and Z was alive for capital Z years, then what I can say is that over their entire lifetime, they must have given V X candies. Like, this must have given V X candies. Then this would have given V Y candies. This would have given V Z candies, right? But let's say V was alive for T years, then it would have lost T candies, and he initially had one candy, right? And when that is equal to zero, like what I have written here is that finally how many candies he has after the lifetime of all his children. Like, if X lives for X years, then he will give X candies to V. So therefore, he will get X from this X, Y from this Y, and Z from Z. And initially he had one, but he also giving to its parent, so he will lose T candies, where T is the amount of time that he is alive. And finally, it is zero. Like, finally, when he dies, he is left with no candies. So therefore, from here we can say that the time that he is alive, that is equal to x plus y plus z plus 1. All right. Is it clear? Okay. So that's why I defined this dp, that dp of v is the number of years that a node v is alive. Actually, I'll just fill this dp for all the nodes, not in a cycle, because in a cycle, all of the nodes will be alive, like for infinite years. So for that, I won't fill this dp. I'll just fill it for all those, the number of years. Like I'll just fill it for those nodes, not in the cycle, right? So let's say I have this test case here. Uh, like this was the fourth test case that we have been looking at repeatedly. So cycle year. Now these nodes are not in a cycle. So I'll just call it dp of v. Like dp of this will be 1 because it remains alive for only the first year. And dp of this is 1. So therefore dp of this will be 1 plus 1 plus 1. So it is 3. So this node is alive for 3 years. So therefore I can just take the maximum of all these nodes. Like when is the last node? When does the last node die? That is the maximum of these nodes, yeah. So after the third year, every node dies, and like plus 2 I'll do, like in the last one. So it is 5. The answer to this test case is also 5, right? So that is the thing. We will have to do dp of v equal to sum of dp of, actually this is parent, right? When I want to write the dp of this thing, the child is this and the parents are these. So I'll just write dp of parents. Or if you're comfortable with dp of children, then you can just reverse the edges and like the dp of children. Then you can write dp of children, like sorry, plus 1. Summation of dp of child plus 1. So this was actually a problem of dp on trees in height side. So like if you do not know dp on trees, you can leave this problem right now. I can't comment on how much it would be rated. Like maybe 1900 or 1800, I guess. I don't know actually. So, anyways, now for the implementation, what I just did was checked, like I first find out cycles, like what cycles are there. Basically, if this is the graph, then I mark all these nodes as being in a cycle. Like cycle detection in a graph is, I think, very easy. So I just did that first, and then for all the unmarked nodes, I first made a R adjacency list, reverse adjacency list. Sorry, uh, I first made a reverse adjacency list, and then just like through DFS, I filled up the DP of all the nodes. So I think it should be clear. I'll just show you the implementation. So I first took the input. Then I have two vectors in cycle, like the marked nodes that are in a cycle, and visited array that for the DFS, right? Then this is the cycle finding logic that I wrote, which is very ugly. Probably there is some other way to find the cycle, which is simpler than this, but I have done this. Like basically this for loop fills the cycle, fills the in cycle vertices, and I define the DP. Like here I define the adjacency list, reverse one, and here Like I did a DFS. Like the DFS function is this, like if for auto children of V, DFS on the children, and then DP of V plus equals DP of children and plus 1 in the end. And if it is already not equal to 0, that means we have called it one time, so we don't need to call it once again. So I just did DFS on all the children if they are not in cycle. If they are not in cycle and not visited, then I just did DFS on them, and then I see out the max element plus. Could I share your ID? Actually, I'll share the submission links. ID is Prady actually. Like I'll just write it if you want. Prady. This is my ID. And yeah, this problem was very good actually. I enjoyed it. It is very clever. So, any doubt in this or any problem up till now? Could this be done using DFS? Um, Technically, I have done DFS only. Like in this for loop, yeah, this is DFS. First of all, this is DFS, the DP, and in this for loop, what I am doing is I am like this is a stack technically. This is a stack, and like basically I'm pushing the child of the current. So it is kind of DFS, but like yeah, you can do recursive DFS. But here there is only one out degree. Like the out degree is one, so you don't need a recursive function. You just need a for loop to do that. This for loop. Yeah. Anything else? Nope. Why can't we use out degree method in this? I don't know what is that. In degree method. Okay. Is it that if the in degree is one, then it is in a cycle, and otherwise it is not a cycle? Is that the thing? What is the in degree method? Like if in degree is equal to one, then the node is in a cycle. Is that what you are saying? But I don't think that's true. Like these two nodes have in degree one, but they are not in a cycle. So that doesn't work. Anything else? Anyone? Okay. I think no doubts are there. So I'll just end the meeting. Thank you for listening to me. Okay. Wait. I meant that I will find all the nodes in a cycle. Find the node just outside the cycle and take max of BP. Yeah, you can do that. Like basically, technically, the max would be all the nodes just outside the cycle, right? Like either this, or suppose if there was then this. Like you are right, but why to do that? Like I can just take the max of DP, right? Yeah, like I can take the max of DP because the the DP of this will be less than DP of this, because yeah, that is obvious because the formula says so. Uh, Anyways, all right. I'll end the meeting. You can leave. Bye, guys.